Welcome back to this video. Today we are going to talk about mathematical proofs, and more specifically the proof by contradiction. So the problem statement of the day is proof by contradiction that the square root of 2 is an irrational number. So the first thing we have to do is to know what an irrational number is. So an irrational number is simply a number that cannot be written in the form a divided by b. It cannot be written in this form. So there are several forms of irrational numbers, and one is on the screen. That's the square root of 2. Now if you analyze the square root of 2, the square root of 2 is about 1.4142135 and so on and so forth. A rational number is any number which can be expressed in the form a and b, such that the greatest common divisor between a and b is 1. So it means that the only number which can divide both the number on the numerator and the denominator is 1. So it definitely tells us that a and b are coprime. Okay, now what actually does it mean for two numbers to be coprime? It simply means that let's say two numbers a and b can be said to be coprime if the greatest common divisor between them is 1. Okay then, so this is the concept of a rational number and an irrational number, and that's how we can actually define them. Now let's prove by contradiction. In order for us to prove by contradiction, the first thing is we can call all of these statements p. So the very first step is that we assume that not p. We assume not p. The next thing we do is we develop the proof until we get to a contradiction. So we develop the proof until we observe a contradiction, then conclude. So in this case, let's follow these particular procedures to see how it goes. Now the first thing is, this is our statement, and we have to assume that this statement is not true. Now we develop the false statement or the assumption that we have made and verify if we are going to get a contradiction. So since here we are trying to prove that root 2 is an irrational number, so the assumption will be, let's assume root 2 is rational. Let's assume root 2 is rational. Now if root 2 is rational, this means the square root of 2 can be written in the form a divided by b, where b should be different from 0. And also what we have to note here is that the greatest common divisor, GCD, between a and b is equal to 1. So the two numbers a and b are coprime. So from here, let's develop now the proof and see if we can get a contradiction. So if we square both sides, we get 2 is equal to a divided by b, all of this squared, which is the same as a squared divided by b squared. And so what does this imply? We can cross multiply, so this means a squared will simply be equal to 2b squared. Now we see that this number a squared is equal to 2b squared actually means that the number a squared is an even number, since it is a multiple of 2. So here what we can see is a squared is even, and also if a squared is even, we also have to get that if a squared is even, then a is even. Okay, so from here one can deduce that a is equal to a certain even number, let's say 2k, where k is some integer. Now let's proceed. So if I replace the value of a equal to 2k in this statement, let's call that equation 1. Now a equal to 2k in that statement, we get 2k, all of this squared, will be equal to 2b squared. So this means we have 4k squared is equal to 2b squared, from where clearly see that 2 can cancel here. So from there we get 2k squared is equal to b squared. In other words, it means b squared is equal to 2k squared. So from here we also see that b squared is even. Hence, b squared is even. And since b squared is even, it also means that b is even. And so, what do we get? This means b can be written in the form 2k, let's say 2n, where n is a certain integer. A contradiction has already been made, because the numbers a and b, the assumption is it should be rational, but what is the condition on a and b? A and b are co-prime, and co-prime in the sense that the greatest common divisor between the two is 1. But here we have the value of a to be 2k and the value of b to be 2n. Let's simplify this further so that you understand. If we go back to our initial assumption that the square root of 2 is equal to a on b, now let's replace the value of a. So the value of a was 2k and the value of b is 2n. So let's put it there. So what do we observe? We observe that the quantity 2 can cancel out. Now just the fact that we can already cancel out the 2's, it means that the greatest common divisor between a and b is no longer 1. And also we clearly see that this number 2 is a common factor between the numbers a and b, which is a contradiction, since we saw that the greatest common divisor of a and b should be 1. So we see that this statement is a contradiction. Hence, all of this is a contradiction. Why? Because the number 2k divided by 2n is not a rational number. It is not a rational number. And if it's not a rational number, it means that our initial assumption that we assume that is rational is not correct. And since at the end of the day we are falling on a contradiction, hence conclude and say hence the square root of 2 is an irrational number. Okay, so with this understanding, drop your ideas in the comment section. I'm going to drop 2 numbers, 2 on 4 and a half. Is this a rational number? Is this a rational number? Why? See you in the next video. Thanks for watching, and please do not forget to subscribe.